Welcome to Computer Science IGCSE, and we are on chapter number 1, data representation. In data representation, we have to continue with the topic of overflow. So what is the basic meaning of overflow? In computers, I told you about the 8 bits register, isn't it? 8 bits register. When we are going to add the 8 bits, you can see in the above example here, example number 3, you see the two 8 bits numbers. Tell me the first one. 0, 1, 1, 0.
1 0 1 1 1 0.
Okay. How many bits are there? Count. 4, 4, and this one is 9th bit, right? Okay. Let's write the other one. 1,
1 0 1 1 1 1 0.
1, 1, 1, 1, 0. I think I have missed any bit. Let me check. 1, 1, 0. Then 4 ones and 0. Okay. Now we are going to add the values. Yes, the first one I think I have write down the 1 extra bit. Now it's okay. Okay, now we are going to add both of the values. Both are 8 bits. Is that okay?
Yeah.
That's great. I need to use a plus sign here. Okay, now I'm going to add the both 8 bits and let's see the answer. So we are applying a binary addition rule here. Okay, 0 plus 0?
0.
0. 1 plus 1?
0 and 1 carried.
Here we go. 1 plus 1? 1.
1 and 1 carry.
Carry. Then again 1 plus 1? 1. 1 carry. Then again 1 plus 1? 0 and 1. 1 plus 1? 0 and 1. Then triple 1 means 1 and 1. And look, 1 plus 1? 0. So there's no number here. So I need to write the remainder value here. Can you count the bits? 1, 2,
2 3 4 5
4,
9.
Yes, 5, 6, 7, 8. And this one is a 9th bit. So it means that this 9th bit is an overflow bit. So this bit will be ignored. You just need to ignore it. And your answer will be 0, 1, 0, 0, 1, 1, 0, 0. So this will be considered as your answer according to the 8 bits. Right?
Yeah.
So this thing is called overflow, where you get an extra 9th bit. But if both bits, like these two registers or the 8 bits, are not 8, they are 9, let's suppose. And if the answer is 9, then it's fine. But if the bits are 8 in number, so their answer should be in 8 bits. Is that okay? So this type of scenario is called overflow. And this error is called overflow error. Right?
Yeah, okay.
So look, the maximum Denry value of 8-bit number is 255. This is a point to be noted. The maximum Denry value of 8 bits is 255. Right? So if there is any extra bit or overflow bit, so that bit will be ignored and it is considered as overflow error. Moving on. Logical shift. Have we done this logical shift topic?
Yes.
We have done this. We have done this. Two's complement is also done.
Yeah.
Positive, negative numbers. Okay. Now, starting from the topic of sound representation. But before that, I'm going to check, is there anything which we left behind, or yes, negative numbers into 2's complement. I think I have given you the homework as well.
Yeah, I did it.
Perfectly fine. No confusion?
No.
Perfectly fine. Okay. Look, example number 2. Convert negative 79 into 8-bit binary number using the 2's complement format. How do you do this? Negative 79. Simple. It is negative 79, so you have to make a register. Remember, I teach you this? So this
Yeah.
register is different. Why? Because you have a negative 128. So for negative 79, you're going to break the binary pattern. Look, this is the answer. And then what you have to do? You need to use a 2's complement format. So in 2's complement method, you need to apply the 1's complement, then add 1, and then you will get this answer. Is it okay?
Yes.
Do you want to try?
Yeah.
I'm giving you one negative, okay, 81. I'm giving you negative 81. And the whole question will be same. You need to solve this question and send me the picture of your answer, okay?
Okay.
Question. Okay, so did you take physics in your subjects?
Yes.
Yes. So you are a physics student and you are smart. It means that you know how sound travels. Tell me quick, how sound move?
It travels in waves.
Yes, look this. This is a wave, right? Okay,
Yeah.
there are two things involved in sound. What are these two things?
Amplitude and frequency.
Exactly. Very good. Amplitude and frequency. So what is frequency? Frequency,
Like the number of waves in a second.
exactly. And amplitude means the loudness of the sound, right?
The
Okay.
sound. Yeah.
So the data which is going to be accepted by the computer, this data, like a wave data, which data it is? Analog or digital?
Analog.
Yes. So analog data is a real data. It means a natural data. Like the light of sun is an analog. The sound is an analog. The weight of a body, right? So these are the things which we are measuring and that are natural are called analog data. But poor computer is not able to understand analog data. So computer understands which data? Tell me.
Digital.
Very good. Let's see. Just as a text can be represented by binary, so too can sound. For a computer to successfully process sound, the analog signal input has to be converted into digital.
Digital.
Very good. Like I'm talking in a mic and my voice is going to be input into the mic. The mic receives my voice in an analog form. But our computer is not able to understand analog data. So what happens in the mic? This analog data is going to be converted into digital data. But how? The question is how. So let me answer. We use, not we, computer use a converter. And the name of its converter is analog to digital.
Digital.
So ADC means analog to digital converter. So this analog to digital converter converts the analog sound into the digital one. So my computer understands what I'm saying to you. So sound is normally captured by a microphone and a piece of software will capture and convert the analog data to digital. This conversion or the recording is called sample. Okay, now the question is, sir, you are speaking in a mic and your computer is able to understand, but how you are able to listen to me in a human way? How? Like, why don't my data is in this form? 10101010101010 like that? It should be like that. Like you have to listen me in a form of binary, but it is not possible because in your computer, once the data is sent, to your computer. Look, it is in binary, but in your computer, again, there is a converter called DAC, digital to analog converter. And this digital to analog converter converts back the digital data again into analog form. And your speaker are going to broadcast my sound, and you're able to understand what I'm saying. So it means how many converters are there? Tell me.
2 converters.
What are the name?
Analog to digital converter and digital to analog converter.
Perfectly fine. It means then you are able to understand my voice. So this thing is called sampling. So the sample is recorded over a period of time, measured in seconds. Look, this is a 1 second. This is a 2 second. This is a 3 second. So in a 1 second, this sound, look, this sound is converted. So the sample generates continuous sound wave that is measure of amplitude over time. So we know this thing. And this bits, like a sound bit converting over a period of time, is called sampling resolution or a bit depth. So the sampling resolution is in 4 bits. Right here, according to this, it is in 4 bits. What is sampling rate? Sampling rate is a number of sound samples taken per second. How many seconds we have here?
6.
6 seconds. So it means a sampling rate of this sound is 6 seconds. Taken per second means you're taking 6 samples. Look, 1 second for this sample, 1 second for this sample, and this thing is called sampling rate. This is measured in hertz, and 1 hertz means 1 sample per second. So this is sample number 1, this is sample number 2, this is sample number 3, this is 4, this is 5, and the last one is a 6. So this rate of conversion is called sampling rate. Any confusion?
No.
Okay, what I want that you need to write down about analog to digital and digital to analog in your own wording. I want sampling resolution definition. I want sampling rate definition. Do it quick.
Okay.
You have only 4 minutes for it.
All right.
Bitmap images means that when we are going to store any image, like, of course, you are using the cell phone, and in your cell phone, there are millions of pictures, thousands of pictures. So every image is made up of a grid. That grid is called, you know that? What it called? A small tiny dots. And
Pixels?
that tiny dots are called pixels. Even you're using the cell phone. So you always go to the shop and you wanted to buy a mobile phone. What type of mobile phone? The mobile phone which have a very sharp camera. Like if I'm saying that you're going to buy a phone which is a cheap camera, are you interested? Never.
No.
You said, sir, why? Why I go with the cheap camera? I want iPhone 15. Oh my God, it's too costly, but it's your wish because you want a good camera phone. So it means that pixels, the camera pixels is a very important word. So pixels means a tiny dot. So if you have a lot of tiny dots, it means the quality of the image is better. So the pixels, the size of the pixels matter in the image quality. Do you get it?
Yes.
So bitmap images are the images which are made up of pixels. An image is made up of a 2D matrix of pixels. So you can see this is a 2D, not 3D. What is 2D? 2 dimensions.
Dimensions.
Right? Okay. So the pixels can be of different shape. So we are going to denote it at with the help of a square or with the help of a circle. So it depends. So the number of bits used to represent each color is called color depth. So it means if you're using a red color here, you can see red color. So it means we have a red color here in the pixel, and this is called a color depth, like the number of bits. Like how many bits are there? Let's suppose 1, 2,
Two.
3, 4, 5, 6. So red color is present in a 6 boxes. So this is a color tab. So I'm going to make it 12. So this time the red color is available in 12 pixels. This type of a thing is called color tab. So the number of bits used to represent each color is called the color tab. What is image resolution? Image resolution refers to a number of pixels that make up an image. Okay. Did you ever see in your laptop a number written like this in your wallpaper?
Yeah.
What is that thing called? Did you ever think? What is that thing?
It's the resolution.
Exactly correct. So what is the resolution? Like what it is denoting? It is denoting the rows and columns. Like 1024 are the rows and 968 are the columns. So look, rows are these things. So if they are 1024 and these are the columns and they are 968. So this means if you're going to multiply them 1024 into 968, you will get the answer. Whatever the answer, that answer is a total pixel, and that totaling is called the image resolution. Do you understand this or not?
Yes.
Rows into columns. So if you're going to multiply them, you got the total pixels in the picture, and that total pixels is called image resolution. Right?
Yeah.
Okay. Let's move on to our ebook. There we go. Contents. Text, sound, and images. There we go. Okay, now let's discuss some other points. As we know, the pixels are going to be represented as a binary number. So each pixels can be represented as a binary number, and a bitmap image is stored in a computer as a series of binary numbers. We already know this thing, that every data is stored in a form of
Binary numbers.
binary. So you can see this, you can see this, you can see this. Whatever the pattern is there, it is going to be represented as a binary. So if we're going to denote these numbers, it means we are going to represent any binary number, and that numbers are representing a bitmap image. So a black and white image only requires 1 bit per pixel. Black and white images. Do you know about black and white images?
Yeah.
Like old pictures. You see many old pictures that are not colored and they are in black and white. So if the picture is black and white, so how many bits per pixel it is using?
1 bit per
1
pixel.
bit. This means that each pixels can be of 2 colors. Okay, so we write 2 here. And 2 power 1. 1 means 1 bit. And why we use 2? Tell me why we use 2.
Because they can be like
Because our data is in binary.
Bi-
Binary means
base 2 numbers.
base 2. Very good. Okay, 2 times 1s are what? 2. So
2
it means how many colors we have? Only black
and white.
or white, or and white. Okay. Now, if each pixel is represented by 2 bits, then each pixel can be of 4 colors. How? Let's see, 2. And if there are 2 colors, so 2 times 2?
4.
4. So 4 colors are represented like 00, 01, 10, or double. Okay, if each pixel is represented by 3 bits, then what happened? 2 power 3. Can you tell me the answer? 8.
8.
Yes. It means the colors are 8. So the
Yeah.
8 colors are represented like this: 000, 001, 010, 011, and so on. So the number of bits used to represent each color is called the color tab. Acha, do you remember, like, if there are 2 power 16, so how many colors are there? Many colors are there. So you are using the cell phone or the television in your home, like LED in your home, are using
Yeah.
millions of colors. Why millions of colors? Because it's 2 power 256. So if you're going to multiply 2 power 256, you will get millions of colors. That is the reason we are going to use the HD or UHD television sets nowadays. So everything represents the bitmap images and the color depth, of course. Got it?
Yeah.
Any confusion?
No.
Okay. So we have discussed already about the image resolution, right? What is resolution? I
Yeah.
told you the total number of pixels we are going to multiply and we will get the image resolution. Let's discuss about the resolution in detail. You have 5 different images. Can you tell me which one is sharp?
A.
And which one is fuzzy?
E.
Very good. What do you think? Why they are fuzzy and why they are sharp?
Because A has more pixels.
Very good. Excellent answer. That's great. So I'm going to give you some homework for now. Activity 1.15. You have to do question number 1 and question number, no, not question number 2. You need to do this one. But before that, you need to learn about ASCII codes. What are ASCII codes? Any idea?
No.
Okay, let me tell you. Basically, ASCII codes are the codes which are being understood by our computer. But how? You use keyboard. Look, this is our keyboard. Whatever you press in the keyboard, like you press A, you press B, you press C, or you press D, whatever. Whatever you press with the help of a keyboard is going to be understandable by the computer in a form of ASCII code. So poor computers not able to understand A, B, C. The computer is able to understand what? ASCII code.
ASCII.
So what is the full form of ASCII? American Standard Code for Information Interchange. So interchange means converting. So whatever we type in the computer like A, B, and C is going to be translated in ASCII first, and then computer is able to understand. So what is ASCII? American Standard Code for Information Interchange. So the ASCII is going to be represented in a form like this. So you see a small a, ASCII, we have 2 categories, decimal and hexa. So A is represented as 61 in hexa and 97 in denary. Similarly, B is represented as
62 in hexa.
D is represented as
63.
D is represented as
64.
Okay, tell me M is represented as
M60.
Do you understand what I'm trying to teach you? Do you understand?
Yeah.
What? Look, there is a sequence of numbers, one after another. And then there is a sequence of numbers, 6A, 6B, 6C, 6D, and so on. This is for hexa. Let's talk about denary. 96 for apostrophe or comma. No, it's not comma, it's apostrophe. Okay, then A, 97, B, 98, C, J. What is the meaning of J?
106.
And so on. This is for small. Let's talk about some special characters. Look, at the rate. In hexa, at the rate means 40. In decimal, 64. And look, these are the capital letters. So if I'm going to write your name in capital, look, I'm writing in capital. Can you convert it in ASCII code?
Yeah.
Take it, Danry. Take the Danry. 65.
65.
5.
9.
Oh no, it's 90. Yes.
90. Yeah.
90. It's 90. K.
75.
75. And again.
65.
So this is how the computer is going to understand what we type into the computer, and this system is called ASCII. So if you got a question like that, so the table will be provided by the examiner.
Okay.
Any confusion?
No.
Great. And then we have, okay, there is another method, another code, and that codes are called Unicodes. What is ASCII? Let's discuss again. ASCII has a number of disadvantages. The main disadvantage is that it does not represent characters in the non-Western languages. It means that ASCII only supports English language. You didn't notice in the table here. Look, only English is there. There is no German, no French, no Arabic. So this is a big problem, because if the ASCII is not going to represent other languages, it means it is limited. And you know the technology is not limited. We want the versatile technology, the unlimited things, right? For example, Chinese. So as seen in the figure 1.6, where we see the ASCII codes, and the ASCII codes are limited. So for this reason, different methods of coding have been developed over the years. And one coding system is called Unicode. So now Unicode is there, which is going to take all the languages. And uni means universal. And code means code, universal code. It means all over the languages which are being used in the world are understandable by the Unicodes. So Unicode represents all languages. But you need to understand one point. English language is only represented by
ASCII.
ASCII, and ASCII's code are taken by the Uni. So Unicode uses the ASCII code for translating English language. Do you understand my point?
Yeah.
Like ऐसा नहीं हुआ कि Unicode have built some other codes for English. No. अगर ऐसा होता ये बहुत बड़ा confusion होता. So Unicode adopted the ASCII codes. Right? So they are following ASCII codes only for English. I think it's clear now.
Yeah.
Great. Okay, so I think it's clear now. I'm moving on. We have done this thing, this thing, this thing, and I'm going to give you activity 1.5. Question number 1. For now, we need to write down explanation of all these things. 5 points are there. So you need to pick only 3 right now.
Okay.